So to solve a simple logarithm equation, either with or without factoring, we need to first identify some important information about solving logarithmic equations. If we go back to when we talked about graphing exponential equations and logarithmic equations, our domain for our exponential equations was all real numbers. This is why when we went to go solve an exponential equation, we had no extraneous solutions. We could just solve and we didn't have to check for any extraneous solutions and excluded values because any number can be x. But we saw in logarithmic equations, when we were graphing them, that our domain ended up being x is greater than or equal to whatever our h value was. So there was a number that kind of started our domain and continued on. That means that there are numbers that are excluded or numbers that cannot be x. That means that you could potentially have extraneous solutions if you're solving a logarithmic equation. Now, what would cause it to be an extraneous solution? Well, the reason why our domain is this way is because we cannot take a number that's positive and raise it to a power and get a negative number. You cannot do that. It's impossible. That means that any time that you end up with a negative number that it's supposed to equal, or the number you're trying to get to is a negative number, then we have an extraneous solution. And if you look at what this looks like as a logarithm, either by drawing your loop or just rewriting it using your base and what number you're trying to get to, we would have log base 5 of a negative number. And I refer to this as my of number. My of number must always be positive. So if you ever get a solution that when you plug it back into your of number, it gives you a negative number, you have an extraneous solution and it needs to be excluded from your answer. So let's take a look at solving these simple logarithm equations. And just like when we had exponential equations, if our bases were common and the same, then we can set our exponents equal to each other. Well, in logarithm equations, if our bases are the same, then we can set our of numbers equal to each other. So I have log base 5 of x squared minus 10 equals log base 5 of 3x. That means that my bases are the same because they're both log base 5, so I can set my of numbers equal to each other. X squared minus 10 will equal 3x. Because this is a quadratic equation, this is an indicator that one of the skills that this is a skill that requires factoring when I have a common base. So we're going to subtract 3x from both sides. And factor this quadratic. A times c, factors of a times c, 1 and 10, 2 and 5. Follow your signs. The sign of the last number is negative, so I can have one positive and one negative. Sign of my middle number is negative, so I want the larger factor to be negative. This means that I'm going to be using 2 and negative 5. Here's your box. First term, first box. Last term, last box. And we'll have 2x and negative 5x rounding out the final boxes. What can I take out of the top row? I can take x. Out of the bottom row, I can take a negative 5. The left side, an x, and the right side, I can take 2. So we're going to set each of those factors equal to 0 to see our potential solutions. Remember, I say potential because there could be extraneous solutions. So I subtract 2 from both sides. And in this one, I'll add 2 or add 5 to both sides. And I get that my potential solutions are -2 and +5. So to find out if these solutions are extraneous, we need to plug them back into our of numbers. So we'll start with -2. -2 squared minus 10 gives me a negative number. This means that -2 is extraneous and we can't include it. Let's try 5. 5 squared minus 10, that's a positive number. And the other side, 3 times 5, that's a positive number. So the only solution I can use is x equals 5. Let's do number 2. I have log base 3 of x minus 5 equals log base 3 of 3x minus 25. The bases are the same, so we are going to set our of numbers equal to each other. X minus 5 equals 3x minus 25. There's no quadratic, so I'm not going to need to factor. We'll just subtract 3x from both sides. And then we will add 5 to both sides. Finally, we'll have to divide by -2. And we get that x is +10. Same process as before. We have to check the of numbers. So we'll have 10 minus 5, which of course you could probably do this without a calculator. But we have a positive number. Check the other side. 3 times 10 minus 25, positive number. So that means I can include 10 as a solution. Let's look at number 3. I have log base 6 of x squared minus 7x equals log base 6 of 8. The bases were the same for the logs, so their of numbers can be set equal. So we'll subtract 8 from both sides, giving us x squared minus 7x minus 8 equals 0, a quadratic equation. Therefore, we have to use factoring to solve. A times c gives me -8. Factors of 8, 1 and 8, 2 and 4. Our last number is negative, so 1 positive, 1 negative is my option. The middle number is negative, so we want the larger factor to be negative. That means that we'll use 1 and -8. First term, first box. Last term, last box. And 1x and -8x will fill out our box. Across the top row, what can I take out of the top row? X. Out of the bottom row, I can take a -8. The right side, I can take x. And the left side, I can take a +1. So we'll have x minus 8 equals 0 and x plus 1 equals 0. Add 8 to both sides and we get x equals 8. Subtract 1 from both sides and x equals -1. Let's check those of numbers. So I have x squared, so 8 squared minus 7 times 8. That gives me a +8. That's what I had on my of number on the other side. Let's try -1. Gives me +8. So since they're both positive, we'll include both answers. Number 4, log base 7 of x plus 2 and log base 7 of 6x minus 3. Since those bases are the same, we'll set our of numbers equal to each other. X plus 2 equals 6x minus 3. We'll need to subtract 6x from both sides, giving me negative 5x plus 2 equals negative 3. We'll subtract 2 from both sides. Negative 5x equals negative 5. And finally, we'll divide by negative 5 on both sides, giving us that x equals positive 1. Double check it. 1 plus 2 is 3. That's positive. 6 times 1 is 6. Minus 3 is 3. Also positive. So 1 is an included solution.